So, what if I told you the single most powerful tool for making business decisions isn't some fancy spreadsheet, but a concept from your old calculus class? Well, today we're going to show you how calculus isn't just for academics. It's the secret weapon hiding in the corner office. All right, let's just jump right in with the biggest question there is. For any business, I don't care if it's a food truck or a giant corporation, there is one magic number. It's the exact production level that will make you the absolute most profit. If you can find that number, you've reached the top of the mountain. The real question is, how do you find it?
To answer that, we've got to assemble our toolkit first. We're going to lay out the fundamental ideas that every business runs on, and then we're going to add a little bit of calculus to give them superpowers.
Okay, first things first, the basics. C of X, that's just the total cost to make a certain number of items. R of X is the total money you get from selling those items. And the big one, P of X, profit, well, that's just your revenue minus your cost. It's what's left over. Pretty simple, right? This is straight up Business 101. But here's where things get really interesting. See, looking at total cost and total revenue, it's like looking at a map from 30,000 feet up. To find the treasure, you have to zoom in. The real magic, the key insight, it all happens right on the edge, with the very next item you make or sell. And in economics, there's a word for that: marginal. And boom, this is where calculus makes its grand entrance. Because when we say marginal cost or marginal revenue, what we're really talking about is the derivative. C prime of X isn't the total cost. It's the specific cost to make just one more item. And R prime of X is the extra cash you get from selling that one more item. Getting this? Well, this is the secret to making really smart decisions. Okay, so now we have our tools, right? We've got cost, we've got revenue, and now we have their marginal counterparts. We are ready for the big reveal. This is the central rule that ties it all together. This is the aha moment where everything is going to click. What's great about this is how intuitive it is. I mean, just look at it. On the left, if selling one more widget brings in more cash than it costs to make, of course you should make another one. You're making a profit on that specific item. But on the right, if the next item costs more to make than you'll get for it, you're literally losing money on that sale. That's a huge red flag telling you to stop. Which leads us to the million-dollar question, literally. If one voice is telling you to keep going and the other is screaming, stop, where is that perfect razor's edge sweet spot? And there it is. The peak profit doesn't happen when you're making a ton of money on the next item. It happens at the precise, exact moment that the revenue from your next sale is equal to the cost of that next unit. If you stop one item short, you've left money on the table. If you make one item too many, you start losing it. This is the absolute peak of the mountain. And this is it's beautiful. It shows you the incredible power of math. That whole complex business strategy, this big idea of a profit peak, all of it gets boiled down to this one simple, elegant equation. Marginal revenue equals marginal cost. That is the key. Theory is great, but let's actually put this engine to work. Let's go down to a factory floor, grab some real-world numbers, and use our new rule to find that magic number for profit. So here's our setup. We've got a cost function, which tells us exactly how much we spend to produce X number of units, and then we have a demand function, which tells us what price people are willing to pay. Think of these as our raw materials. Before we crunch any numbers, let's just picture this in our heads. Imagine a graph. Your total cost is a red line, and your total revenue is a green line. Your profit? That's just the gap between the two lines. Our goal is to find the exact point where that gap is the absolute widest. And here is how our rule connects to that picture. Remember, the derivative of a function just gives you its slope at any point. So when we say R prime equals C prime, what we're visually looking for is the exact spot where the slope of the revenue curve is perfectly parallel to the slope of the cost curve. That's the point where the gap, our profit, is at its max. So cool. Okay, let's do the math. It's a three-step process. Step 1, we create our revenue function. We just multiply the number of items, X, by our demand function. Bam, we have R of X. Step 2, time for calculus. We find the derivatives of both our revenue and cost functions to get the marginals, R prime and C prime. And finally, step 3, the big one, we set them equal to each other. We put our rule into action. Now, once they're set equal, it's really just a little algebra. You move the X's to one side, the numbers to the other. And that whole complicated setup, it boils down to this one simple line. 9 equals 0.012 times X. And when you divide 9 by 0.012, you get the answer 750. That's it. That's the magic number. For this factory to make the most profit possible, they need to produce and sell exactly 750 units. Not one more, not one less. But you know what's really cool? This whole derivative toolkit isn't a one-trick pony. Maximizing profit is just the beginning. This same core idea can unlock answers to a bunch of other really important business questions. For instance, what if you just want to be as efficient as possible? Well, you can create an average cost function. Just take your total cost and divide by X. Then you find its derivative, find where that equals 0, and it will tell you the exact production level to become a lean, mean, cost-efficient machine. Or how about pricing? You ever wonder how companies know the perfect price to set? Well, a concept called elasticity of demand uses derivatives to measure how sensitive customers are to price changes. Will they leave if you raise the price by $1? Calculus can help find that perfect price that balances everything out to maximize your revenue. So when you step back and look at the whole picture, it leads to this one conclusion. From finding the perfect price to building the most efficient production line, calculus really is the engine that drives modern economic strategy. It's the tool that turns business from a guessing game into a science. So I'll leave you with this thought. This core idea we use today, finding the perfect spot by setting two competing rates of change equal to each other, it isn't just for business. It's a fundamental pattern you see in logistics, in engineering, even in biology. So think about it. Where else in our world can this elegant idea help us find the perfect balance? Thanks for joining me.